Hey, Banks Goodell third graders, it's Miss Sumners. Any of you who know me know I love chocolate. And so I got myself a little bit of a treat here, but I am trying to decide. Do I want to eat half of the candy bar or do I want to eat 6/12 of the candy bar? I'm going to need some help to figure this out. Okay, so to figure out my candy bar problem, I'm going to go back to what I know about fractions. And today we're going to talk about equivalent fractions. So our goal is to understand the meaning of an equivalent fraction and to be able to find equivalent fractions. Let's review a vocabulary term before we move on. Talk about the term one whole. When we talk about one whole, we're talking about when the parts of a fraction are all there. When we're counting all the parts, then it is equal to one or one whole. Here we have one whole drawn in a circle. We could divide that into two equal parts, and each part could be labeled 1/2. But if we have both of those parts that we are counting, then we are counting one whole, the whole circle. So 2/2 is equal to or equivalent to one whole. So which of these fractions would equal one whole? 2/3. Well, that means we're counting only 2 out of 3 total pieces. So that's not one whole. 1/3, then we're counting only 1 of 3 total pieces. That's not one whole. 3/3, we're counting all 3 out of 3 total pieces. So 3/3 would be equivalent to one whole. So what are equivalent fractions? Well, equivalent fractions are fractions that name the same amount, but they have different numerators and denominators. I wonder what that means. Well, let's look at our circle. We have 1/2 of the circle labeled here. So we're representing 1/2 of the whole circle. Now, on this side, we're labeling it 2/4. We're going to take that same circle and we're going to break it into 4 equal pieces. So here's 1/4, 1/4. We could draw this line across and we would have 1/4, 1/4. So if we are only counting 2/4 of this circle, that is the same amount as 1/2 of this circle. It takes up the same amount of space. So they're sometimes called equal fractions. 2 or more fractions that name the same number are equivalent fractions. Let's look at some more examples. Here we have 1/2 of our rectangle that is green. In the next rectangle, we're going to take that same rectangle, it's the exact same size, and this time we're going to break it into 4 equal-sized pieces. Here we had 2 equal-sized pieces. Now we're going to have 1, 2, 3, 4. Of those 4 equal-sized pieces, 2 of those are green. So the fraction to represent this rectangle is 2/4. But if we look at these next to each other, the part that is green here and the part that is green here is the same size. It takes up the same amount of space. Okay, let's try again. We're going to take this rectangle, and this time we're going to split it into 6 equal-sized pieces. Again, the rectangle is exactly the same size. We have the same whole that we are working with, and this time we have 3 out of 6 pieces that are green. So 3/6 is equivalent to 2/4, which is equivalent to 1/2. half. The fractions have different digits. The numerator and denominator are different, but the value of the fraction, the amount of space that it occupies, is the same. Now, I could take this same rectangle and I could split it up again. And this time I could break it into 8 equal-sized pieces. And 4 of those pieces are green. So that would be 4/8. We could break it into even more pieces, and this time we have 10 equal-sized pieces. 1, 2, 3, 4, 5 of those pieces are green. So 5/10 is equivalent to 4/8. It's the same size that is green, which is equivalent to 1/2. We could also do this with a circle. If we have half of our circle is blue. This time I've taken my circle and I've split it into 8 equal-sized pieces. 4 of those pieces are blue. So 4/8 of the circle is equivalent to 1/2 of the circle. So now let's go back to my candy bar. I'm trying to decide which is going to give me more, if I have 1/2 of the candy bar or 6/12 of the candy bar. Let's open the candy bar up and see what we think. Okay, here is my Hershey bar. If I'm going to break this Hershey bar in half, then I'm going to go right to the middle here to break it. And I'm going to check and make sure that I have the same number of pieces on each side. So if I break it right here, then I have 1, 2, 3, 4, 5, 6 pieces on this side. 1, 2, 3, 4, 5, 6 pieces on this side. So I'm going to break my candy bar and see that my pieces are the same size. Okay, so this is 1/2 of the candy bar. Well, what if I take this candy bar and I break it into 12 pieces? So each of these little rectangles is a single piece. Okay, so I've counted and I know that I have 12 individual pieces that make up this whole candy bar. So if I take 6 of these pieces, 1, 2, 3, 4, 5, 6. I want to know if that is equal to 1/2 of the candy bar. Well, here is 1/2 of the candy bar. I'm going to take my 6 pieces and I'm going to lay them on top. So 6/12 of the Hershey bar is equivalent to 1/2 of the Hershey bar. It is the same size. So I could write this as 6/12 is equivalent to 1/2. When you are comparing fractions and looking for equivalent fractions, you need to make sure that the whole that you are comparing is the same so that you can compare the size and number of pieces to see if they are equivalent.